is Dr. Devashish Mishra. So today we will discuss reciprocity theorem. So we will see the definition. In any branch of a network, the current I due to a single source of voltage V elsewhere in the network is equal to the current through the branch in which the source was originally placed. When the source is placed in the branch in which the current I was originally obtained. Okay, so I will explain the definition. If there is a source and you find the current across a particular branch and you change the source from that particular side and find the current, and both the current will be same. So whenever we will discuss with example, it will be clear. Explanation. In simple sense, the location of voltage source and current may be interchanged, whatever I told, without a change in current. However, the polarity of the voltage source should be identically with the direction of branch current in each position. So it is a very important question. What are the limitations of reciprocity theorem? It is applicable only to single source network, not to multi source network. Okay, it is very important. The network where reciprocity theorem is applied should be a linear one and containing of resistors, inductors, capacitors and coupled circuits. So these are the limitations. The network should have any time varying elements. The network should have any time varying elements. So these are the limitations. Procedure for solving the reciprocity theorem. Step 1, we have to choose the branches in the circuit where reciprocity is to be established. So we have to choose first. Step 2, any conventional network analysis approach may be used to determine the current flow within the branch. Any type of method you can find to get the current. The voltage sources can be interchanged between the branches that have been chosen. Measuring the current flow inside the branch wherever the voltage source previously existed. It may be observed that the current obtained in step 4 and step 4 are equal to each other, so that we can say the reciprocity theorem is proved. Prove that reciprocity theorem is applicable to this network. So this is the problem. I am just explaining the problem. This is 10 volt and this is your I1 current, this is your I3 current and this is your I2 current. Okay, so first of all we will calculate the current I2 which is flowing through A and B. Okay, so this is 10 volt. Due to this 10 volt we will calculate the current I2. Okay, after that this 10 volt will come here. Okay, and we will calculate the current through X and Y, and we will see that this current and this current will be same. So this is reciprocity theorem. We will go step by step, no problem. Let us assume that the validity of the reciprocity theorem in branches X, Y and AB. We will see, we will check whatever I told X, Y and AB. For that we have to do first calculate the current through the branch AB. So if I will calculate the current across AB, then what will be the R equivalent? I am just explaining, my dear students. You can see from this side same current flowing through 1 and 2. Okay, So 1 and 2 is series. After that 3 parallel. So now the circuit diagram will be like this. You can see here, this is 2, this is 3. After series, your circuit diagram will be like this. So now this 3 and these 3 both are parallel, then series with this. So 2 plus 1 parallel 3 plus 2. So answer will be 3.5. Clear? Then I1 will be, total voltage is 10 and resistance is 3.5. So it is 2.86 ampere. So here I1 is 2.86 ampere, but we have to calculate I2. So the current I2 through AB can be calculated by using the current division rule. So what is that rule? So I2, we have to calculate I2. So what will be the formula? I2 is equals to, this is I2, total current I1 into opposition resistance. We have to calculate this I2. So opposition resistance is 3 divided by total resistance. 3 plus 1 plus 2. 1 plus 2. Simple, very simple. So answer is 1.43 ampere. Clear? Going to the next. Change the location of the voltage source and place it in branch AB. Now source was here and I just interchange the place. Now it is 10 volt. We have to find the current here, I1 current. We want to determine the current value in XY axis, because we have already calculated the current across AB, which is the branch where the source was identical, initially stored before being transferred to branch AB, where we calculated the current. The following calculations are used to determine the equivalent resistance AB. Equivalent resistance we will calculate. So equivalent, what will be the equivalent resistance? You can see 2 and 3 both are in parallel. After that series. Clear? You will see from this side. Because source is here. 2 plus 1, 2 different current. So it is parallel. After that 1 plus 2 is series. So it is 4.2 ohm. Clear? Then current I2. This I2, total voltage is 10 volt and resistance is R equivalent is 4.2, so it is 2.38 ampere. So for calculating I1, this is I1. So what will be the formula? Same current division rule. We have to calculate I1. I1 is equals to, total current is I2 into, we have to calculate I1. So opposition resistance will be 3 divided by total resistance, 3 plus 2. So it is I1 equal to, I2 is 2.38, then 3 by 3, 1.43. So before we have got the result 1.43, yes or no? So as a result, I1 and I2 have the same value, hence reciprocity theorem proved. Okay, so you remember reciprocity theorem is applicable only for the one source element, and if you will change this source to the another place and whatever current here, and after changing the source you will get the same current. So that is reciprocity theorem. Thank you.